Today we're going to talk about that mountain there, which is known as the Lomond. You probably recognise it. Now, if you've ever been up there, you'll probably realise, and probably have taken some rocks home with you as well, that the rocks are all shiny, all glittery. Now, have you ever wondered how those rocks formed and why they're shiny and glittery? Well, I'm going to tell you, okay? These rocks are part of your Dalradian supergroup. Now, we've spoken about the Dalradian supergroup before. It's actually a metamorphic rock, and it was caught up in all that mountain building that happened 450 million years ago. Well, where did these rocks originate from? Well, they were originally deposited as sandstones, siltstones and mudstones, right? In the Iaptus Ocean, as sand, silts and muds. They were then compressed, turned into rock, and then pushed up and caught up in the two plates colliding with each other, Avaloria and Laurentia. We've spoken about them before, haven't we? Yes, we have. Now, when this closure happened, known as the Caledonian orogeny, when you had the closure of the Iaptus Ocean and the continents collided with each other, you had all this mountain building. And all the mountain building fluidity pushed and squeezed the rocks. It caused the minerals in the rocks to change, which is known as metamorphism. And when that happens, the rocks are buried at immense pressures and temperatures, and you get index minerals that show up in the rocks as well. Now, the minerals want to align a certain way. So in these rocks behind me that make up that mountain, they're all aligned, which suggests it was regionally metamorphosed, okay? Regional metamorphism, remember that one, happens on a big scale, usually where there's mountain building events, okay? Now, because they are aligned, it means that when they were buried deep within the Earth's crust, the minerals are just, you know, sitting there and warming up, and they're under pressure, and all the elements within the minerals just want to move about. So there's all these different chemical reactions that happen. You've got hydrothermal fluids running through it, and that's why as well you find quartz veins up there. You find quartz veins running through all of these rocks in the Dalradian supergroup. And it's mental. Now, the evidence in these rocks behind me as well suggests that it was deposited within a marine environment. You've got grits, you've got pebbles as well. It's mental because the original sedimentary features that you can find in the rocks, some of them are still there. But every now and then, you know, you have the regional metamorphism, you actually have more of that seen in the rocks than the original sedimentary features. So they've not been at high pressures and temperatures. They've probably got some chlorite in there as well, maybe been to 300, 400 degrees Celsius buried within the ground, right? For an immense, yeah, a lot of time, as in geological time, millions of years, okay? That's how they formed. They're part of the Ben Luddy Grit Formation, part of the Southern Highland group, I think it is. Probably got that wrong, which is part of this Dalradian supergroup. How cool is that?